Today we're talking about polynomial and polynomial-like equations in one variable. We're talking about polynomial and polynomial-like equations in one variable. So when you hear one variable, what are you typically thinking? X? Yeah. We can use that as our one variable, right? So the thing that we want to do here, we want to learn how to solve quadratic-like equations, solve general polynomial equations by factoring, and solve polynomial-like equations by factoring. So we're taking some methods that you like, and we're going to solve different kinds of equations. Now, it may look... Is there a question?
Oh, no, I'm just saying.
Okay. It may look a little different, but we're brilliant. We can figure these things out. So try not to panic. Let's remember what we remember and work our way through it. Okay? So let's start out with the definition. Make sure everybody's together on the terminology. Remember, you need to constantly remind yourselves of what the terms mean so you understand what questions are asking for. What can you also use in addition to your notes? The Math Dictionary app, right? So make sure you do that. Okay, so let's start out with the definition. An equation is quadratic-like. Or quadratic in form, that's a Q, or is quadratic in form if it can be written in the form little a times capital A squared plus b times capital A plus c equals 0, where a, b, and c are constants. Little a is not equal to 0, and capital A is an algebraic expression. So what we're saying now when we say capital A is an algebraic expression, we're saying that it can look something like maybe x squared plus 3 or x plus 2. We're saying it's an actual expression now. So we may have to do what's called, quote unquote, a substitution, right? But it's still going to boil down to solving a quadratic equation first. So it's quadratic-like if it has a similar form to a quadratic equation, which remember we discussed at the beginning of class by saying that was ax squared plus bx plus c equals 0. So notice that this equation is like this one, but instead of x, we have an algebraic expression, capital A. That's all we're saying. Okay? A note, equations in the definition above can be solved by first solving for capital A and then solving for the variable in the expression capital A. This method of solution is called substitution. It's called substitution. So the best way to learn these things is to get our hands dirty with it. So let's go ahead and jump in and do an example. Okay? You with me? Yeah? All right, let's do it. So you can pay attention. I know many of you said you're visual. Feel free to pay attention. And after we go over it, I'll give you time to write. Okay? Do you want to try it that way for the first one? Okay. So we want to solve the following quadratic-like equation. Is that small for you in the back? It looks small to me. That better? All right. So we want to solve the following quadratic-like equations. Well, our first part, to example 1, says we have z minus 8. What is that? Squared, yes. Minus 7 times the quantity z minus 8 plus 12 equals 0. Now, this looks a little bit different than what we solved in the previous section because instead of an x, we have z minus 8, right? But if we just think of the z minus 8 as an a, as this capital A, so we're going to let a be equal to z minus 8. I'll draw a line through my z's so you can differentiate them from my 2's. Okay? So we're going to let a be equal to z minus 8. Then I'm going to call this line smiley face because I don't want to rewrite it. Okay? So then smiley face becomes what? If we are substituting z minus 8, are we substituting a with z minus 8? Capital A squared. I'm sorry, say that again. Minus 7. Yes. Yes. Does everyone see that? Okay. So something that started off looking a little challenging has become a little bit simpler by doing the substitution. Oh, I forgot to silence my phone. My bad. There we go. So what happens when my phone does that? My word. I need to go outside? So we need to take a break. I need to go outside? My word. So we now have a squared minus 7a plus 12 equals 0. You got all the methods in the world to use. You have 4. Which one you want to use? Factor. Yeah, let's factor it. Okay. So we factored this as what goes in the first spot? A and A. And then you said what combination? I heard it. 4 times 3. Are both positive or is anything negative? Oh, they're both negative, yeah? So a minus 4 times a minus 3 equals 0. So then using the 0 property, that means a minus 4 equals 0 or a minus 3 equals 0. If a minus 4 is equal to 0, that means a equals what? Yes. And then the other means a equals? Yes. But what's our goal to solve for a?
No.
What's our goal to solve for?
Z.
Z, right? So then you have to go back in and substitute. So we found out what a is. We know a is z minus 8. So this means z minus 8 is equal to 4. The other means z minus 8 is equal to what?
3.
Yes. So we do what to both sides of the one on the left?
Plus 8.
Add 8, yes. To get z equals? Yeah. Z equals 12. And then what do we do for the other?
Plus 8.
Plus 8, yes. To get?
12.
We get what?
Z equals 11.
Oh, yeah. Z equals 11. Yes? So our solution set consists of 11 and 12. That's our final answer. What questions do you have? Yes?
How did you get 4 and 3?
How do we get, so the question is, how do we get 4 and 3? That's an excellent question because we want two numbers. I'm going to use green. Well, let me not write over it. I want to highlight it. We want to use, or we want to find two numbers such that when we multiply them, we get a positive 12. So negative 4 and negative 3 gives us a positive 12 when we multiply them. But why did we choose negative? We chose negative because whenever we take into account that we're using our first term or our outer term and our inner term, when we add them up, we want to get negative 7a. So whenever we multiply this times, I'm going to put a line underneath so you can still see the green, that times that, plus this times this, we want to get negative 7a. Does that make sense? Okay, so that's why we chose negative 4 and negative 3.
Thank you.
You're welcome. What other questions do you all have? I promise I'll give you time to write, so you can have time. Is everyone good?
Yes.
All right, let's keep it moving. Another equation, quadratic-like, but doesn't look like it yet. We have 2 times x to the 1/2 minus 5 times x to the 1/4 plus 2 equals 0. Okay? Now, this may look a little different because you have fractions as exponents. So one thing I'm going to do is I'm going to pause and say that, remember, and you don't need it right now. Well, so because you don't need it, let me not even say it. Okay? Scratch that. Okay? We're going to start out by saying that we're going to let a be equal to x to the 1/4 because I'm going to write down y, because x raised to the 1/4 times x raised to the 1/4, whenever we multiply two expressions like this that have the same base, but the exponents are different, that means with our laws of exponents, we keep the base and we add the exponents. So that will be 1/4 plus 1/4, which is 1 plus 1 over 4, because the denominator stays the same. Are we all right? Okay. And that's equal to x raised to the 2/4. 2 over 4 is the same thing as what? Yeah, that's the same thing as 1/2. Bless you. You're welcome. Same thing as x to the 1/2, right? So all of that to say that this x to the 1/2 is really x to the 1/4 squared. So all of that to say that smiley face becomes, bless you, you're welcome, becomes 2 times a squared minus 5 times a plus 2 equals 0. What questions do you have so far? Yes.
So we're substituting.
Talk loud.
So since we so we're substituting x to the 1/2 and x to the 1/4.
So we're substituting x to the 1/4 for this. So let me, before I use a, your question makes me want to rewrite this as 2 times x to the 1. Oh, my iPad doesn't like the spot, so let me move down a little bit. 2 times x to the 1/4 squared minus 5 times x to the 1/4. What?
Oh, so that would be.
Yeah. Does it help to see it this way first?
Yes.
Okay. Plus 2 equals 0. Does that make sense? What other questions do you all have? Yes. Talk loud. Tell me where to start. The fractions, okay? So one thing that you want to remember, whenever you have, ignore the base for a second. I'm going to do this all on the same sheet because it's the same point, but I'll erase it once I'm done. If you have 1/4 plus 1/4, what is that? Can't hear you. 2/4, yes? And 2/4 is the same thing as what? A half, yes? So all I'm saying from using this information is that whenever you have x to the 1/4 times x to the 1/4, that means you get, let me write a step in between here. That means you get x to the 1/4 plus 1/4, which is then equal to x to the 1 plus 1 plus 1 over 4, which is x to the 2/4. That's x to the 1/2, using this concept. You got to tell me where you lost, though. Before you said with fractions. I can't hear you. Does the fraction part make sense now? Because before that's what you said was fractions. I need you to talk a little bit louder because I'm trying to understand you at the front. This part? So remember your laws of exponents. Your laws of exponents says that x to the n times x to the m is x to the n plus m. That's the laws of exponents. So you have x to the n times x to the m is equal to x to the n plus m. This is what we're using to go from this step to this step. So it's going to be helpful, as you see, to review your laws of exponents. So review laws of exponents. And what will be helpful, you can go to Khan Academy, type in laws of exponents. It'll give you a quick review. You with me? Okay? But I'll give you what you need to get through this part. Okay? Before a bigger review, you can go there. Yes?
So is there ever an equation where the exponents are not going to be like correlated with each other?
For the purpose of this class, I'm going to always give you something where you can simplify it a certain way. For those equations that you just asked about, then the methods of solving is different. Right now, we're talking about equations that are quadratic-like in form, so we should be able to rewrite them in a form where it looks like a quadratic equation. Yes?
So did the 2x squared come from the 1/2 plus the 1/2, and then it goes 1?
You said the 2x squared or the 2a squared?
2a squared.
The 2a squared, did that come from what?
The 1/2 b squared, which equals to 1/4.
Did it come from, say it one more time,
Okay, so when you add 1/2 and 1/2,
when you add 1/4 and 1/4?
yes,
Yeah, go ahead.
that's where that came from.
That's exactly where that came from. Because here, we were able to write x to the 1/4 times x to the 1/4, which means we have x to the 1/4 quantity squared, right? So that's where this came from. Yeah. What other questions do you all have? Okay, ready to keep moving?
Yeah.
Okay, so we were able to rewrite our original quadratic-like equation, 2x to the 1/2 minus 5x to the 1/4 plus 2 equals 0, as 2a squared minus 5a plus 2 equals 0. Yeah? Okay, so we can go through and we can solve. You said you like factoring, so that's the way I'll write it out. So you have the quantity, a quantity times another quantity equals 0. In the first spots, we can write 2a and a. Those are our only options because 2a squared, to get it, you have to have 2a and you have to have a. Okay? Now, the option for 2, now take into account, we want our middle term to be negative 5a. This is what we want our middle term to be. But we need two numbers that multiply to be 2. What are they? What are they? 1 and 2. Do we want positive or do we want negative? Oh, I heard both. Negative and positive. Which one? You need a minute to talk with your neighbors?
If it's positive 2, it should be negative.
Can't hear you?
If it's positive 2, should we do positive? But negative is negative.
So it's a negative?
So they should be negative.
They should what?
Negative, because you're multiplying negative to get a positive.
Oh. Does everyone agree?
Mm-hmm.
Yeah? No? I hear one saying no. What'd you say? They said, what did you say?
I said, so they should be negative because you're multiplying negatives to get positive.
So she's saying you should have.
When you add them, it will be a negative number.
Does everyone hear that? So she's saying, let me repeat what she said a little louder. She said you want negatives because when you multiply these two, when you multiply negative 2 and a negative 1, it comes out to be a positive 2 But whenever you put them here, she's saying the middle term is going to be a negative.
Can I ask you a question, though?
Yeah.
And in my opinion, I feel like it don't matter what we multiply because I don't think we may be able to reach to get to 5, right? Because we got.
Why not?
Because when we fact, so we got 2 right there, right?
Yeah.
We need to multiply.
You got 2 where?
Right on the end. What's C?
Here?
C, yeah.
Yeah.
So you're supposed to multiply whatever terms that gets you 2. So 1 times 2, right?
Yeah.
So that 1 times 2, those two numbers carry over to that one that has to equal the negative 5.
It has to equal to negative 5. But what else do we have in play that's going to help us get that negative 5?
The 2A.
Ah, the 2 in front of the A. That 2A is going to help us get a negative 5A if we use the negative 2 and a negative 1. So, yeah, they're saying what? And that's pretty much why he was asking the question. I'm going to keep the recording rolling so you all can hear this whenever you watch the video. Okay? So, you want 2 numbers that multiply to give us a positive 2. But whenever we take into account that we want our middle term here, oh crap. There you go. When we take into account we want our middle term to be negative 5A, whenever you're using the FOIL method, which parts of the FOIL, the F, the O, the I, or the L, gives us this negative 5A? Yes. Using the FOIL method, the F, the O, the I, or the L, which ones gives us this middle term? I'm asking you for an F, O, I, or an L. Outside?
I think so. This is like a step, no?
Outside? And the inside, yes? So whenever we add the outside term and the inside term, we should get a negative 5A. Yes? So, the question is going to be, I'm still answering the last question. The question is, because he said he feels like that whenever you have a negative 2 and a negative 1, we cannot get a negative 5. Yes?
I think you showed it to us yesterday, like you multiply the 2 outer and then multiply the 2 inner and then you add them 2 together and it should get negative.
That's right. We should get the negative 5A. That's absolutely correct. So tell me where you want negative 2 to go and where you want negative 1 to go. So negative 1 should go here. So we should have 2A minus 1. So we should have A minus 2. Yes? Very good. Very good, both of you. Because see here, when you multiply 2A times negative 2, what is that? What is it? Say it loud, everybody. Negative 4A. And what is negative 1 times A? Negative 1A, yes? So negative 1A plus negative 4A is negative 5A. So it works. Yeah. So even though it didn't look like the negative 2 times the negative 1 is going to give us what we need, it actually does, because we have to take into account we have a 2A here and an A. Okay? We good? Yes? No?
Yes.
Okay. So then we're at a point where we can do what?
Equals 0.
Yeah. So we have 2A minus 1 equals 0. Or we have A minus 2 equals 0. Solving the first, we do what to both sides? No. We don't subtract because it says 2A minus 1. So we have to do, yeah, we got to add the 1 to both sides, which gives us equals, yeah. Then we do what? Divide both sides by 2. To get A equals 1/2. But really we need to solve for what variable? X, yeah? So we're going to go ahead and solve for X. Say it again? Yeah, let's go ahead and do the other side. So we need to do what to both sides?
Had to.
Yes. To get A equals? Yeah. Okay. So we have A equals 2 and we have A equals 1/2. Which one do you want to solve for X first? 2, you said? Okay. God bless you. So, remember A was what? What did we say A was? A is 2, yes, but for our substitution,
X to the 1/4.
yeah. So, remember our goal is to solve for X, right? Our goal is, bless you. Our goal is to solve for X. So we have X to the 1/4 equals 2. Now we really want X by itself. So what should we do to both sides?
Take it, solve.
Y'all love fractions, right? What times 1/4 equals 1? Yeah, so we don't need to multiply each side by 4. Say it again. No. So if you're saying, so I'm just going to write down. If you're saying we need to multiply both sides by 4, this is what you're saying, but that's not really what you mean. Right? Because this will then give us 4 times X to the 1/4, but we really want to make this exponent a 1. So instead of multiplying by 4, we need to not but divide by 4. No.
It wouldn't be the whole.
Yes.
It would just be the exponent.
Make this 4 over 1. It's still going to be multiplying times this X.
Wouldn't we only multiply the exponents?
Yeah. So you really want to, instead of putting this 4, oh, it's moving slow. Come on. It's frozen. There we go. We really want to, you said just multiply the exponents by 4. So that's the same thing as saying we want to raise both sides to the 4th. Good. So this is going to be X to the 1/4. All of this raised to the 4th. Let me go back and write our fraction like this so you can see it a little better. Equals, what you do to one side, you have to do to the other. 2 to the 4th, yeah. Now, here, the 1/4 times the 4 is 1, right? Which leaves us with what on the left side? Yeah, which is exactly what we wanted. So we have X equals what?
60.
You got it. Very good. And so then we have to go back and we have to do the other side. A equals 1/2. Are we okay so far? Okay. So I need to minimize this a little bit to give us a little bit more writing room. Can you all still see that? Bless you. All the sneezes today. You like the rain? So you have A equals 1/2. So this, remember, is the same thing because of room, writing room. This is the same thing as X to the 1/4 equals what? 1/2, yes. Now what do we need to do to both sides? Can't hear you?
Raise both sides of the 4th power.
Yeah, raise both sides to the 4th power. So that's X to the 1/4 raised to the 4th equals 1/2 to the 4th. So what do we have?
X equals 160.
Very good. X equals 1/16. So our two answers are
116 and 16.
good. Very good. It's our final answer. What questions do you have? What questions do you have? Okay. So let's keep going. Let's keep going. So a fact. What? You sure?
I was just looking.
Okay. So a fact. For higher degree polynomials, when I say GCF, greatest common factor, the greatest common factor factoring method, GCF means what? Yes, greatest common factor. For higher degree polynomials, the greatest common factor factoring method and factoring by grouping can be very effective. So we're going to try that here. We're going to solve the following polynomial equations by factoring. Okay? So we have 2x cubed plus x squared plus 2x plus 1 equals 0. Okay? So let's try to factor by grouping. Okay? So I'm going to put parentheses around 2x cubed plus x squared plus, and then I'm going to put in parentheses 2x plus 1. We didn't change the equation, we just grouped. Okay? Now, these terms here have what in common? They have what? No, I'm asking what do they have in common? They just have an x in common?
And exponent.
They have 2x?
X
No,
squared.
x squared.
Oh, they have x squared in common.
Mm-hmm.
Everybody agree?
Mm-hmm.
Okay, so let's factor out an x squared. So that leaves us x squared times what quantity?
2.
2x plus 1.
Everybody agree? Okay, then plus what quantity?
2x plus 1.
Yes, equals 0, yes? So look what happened, right? So whenever we group them and we factored out that x squared, those two are the same now, right? So that means now technically in front of that last 2x plus 1 is an understood what? 1, yeah? Understood 1. Only writing that like that so you can just see. So really, at this point, if we factor out the highlighted portion, that would then leave us with the quantity 2x plus 1 times, you said squared? So now what we're doing is we're factoring out this yellow part from each grouping, right? So we're left with what?
X squared.
2x plus 1.
We factored out a 2x plus 1 from here.
You said, oh,
So we're left with what?
1,
X
No,
squared plus 1.
2x.
I'm not sure.
you're guessing. Pause. Wait. Look, wait.
Oh, is it X?
Wait. And I'm not saying you're incorrect. I'm just saying pause. Let's make sure we all see this thing the way we see it. Okay? This is x squared times the quantity 2x plus 1 plus 1 times the quantity 2x plus 1. I'm saying at this point, we're going to factor out this highlighted yellow part. So when we pull this out from here, what are we left with? X squared plus 1 because we pulled this part out. Are we good? Oh, okay. So we're left with x squared plus that 1 equals 0. Okay? So something that looked challenging initially, we were able to factor by grouping, which allowed us to have this equation in a FOIL method, which is factored already, and now we can solve. All right, so let's do it. Let's finish it. So then we have 2x plus 1 equals 0, or x squared plus 1 equals 0. 2x plus 1 equals 0. We need to solve it. What do we do? Yeah. Keep going. Can't hear you. Say it aloud.
2x equals 1.
Yes.
2x equals 1.
Good. Both of you. Okay. X squared plus 1 equals 0. What do we do?
-1.
What would -1?
-1, yeah.
Oh, okay. Keep going.
And after that, you drop it. You get the square root.
We take the square root of what?
X squared.
Oh, so what do we get first before you start taking the square root?
X squared equals -1.
Y'all better write this stuff out.
Then you take the square root.
Then we take the square root of both sides. Yeah? I'm looking for justification as well, so make sure you write it out. So yeah, take the square root. You're right. Go ahead, keep going.
And I don't know.
Then it's x equals 1i.
Say what?
Plus minus.
Oh, x equals what?
Plus minus.
Plus minus what?
Another square root of -1.
1i?
Yeah. Yeah. Plus or minus I. Remember plus or minus. Remember plus or minus. When you take the square root of both sides, you have plus or minus. Okay? Square root of -1, you remember is I. So that's what we had. So tell me our solution set.
-1 plus minus
Y'all talk loud. -1/2.
comma plus minus I.
Plus or minus I. Got it. Good. What questions do you have? Y'all love it that much? Yes? Square root, whenever you take the square root of both sides, you end up with whatever equals plus or minus. Yes. What other questions do you have? That's it? Okay. Let's look at another example. I really put way too many examples. We don't need to do every single one. We really don't need to do every single one. We'll do both of these and we'll choose one from the last page. Okay? Here, this one has a special formula. And almost always on our practice exams, we give one that's similar to this just so you can say you've been familiar with it. I don't expect you to have this following formula memorized, that if you have a cubed plus b cubed, you can write this down. If you have a cubed plus b cubed, this is something I would give to you, but you'd have to know when to apply it. You with me? Mm-hmm. Okay. A cubed plus b cubed equals the quantity a plus b times the quantity a squared minus a times b plus b squared. What? So this is saying, if you're adding two numbers, that if you have a sum of cubes, this is how you can factor it. Notice here, we have y cubed plus 8 equals 0. 8 is the same thing as what? Think about, I gave you this formula.
Oh, 2 cubed.
Oh, okay. Yeah, you put it together. It's not random. You have y cubed plus 8 equals 0, which means this is really y cubed plus 2 cubed equals 0. So what is acting as your a? Y, yes, and what's acting as your b? 2. So go ahead and take a minute and factor that. Yes? The 2, 8. So in lieu of me giving you this formula, you have a cubed plus b cubed equals this as it's factored. Y cubed plus 8. 8 we can think of as 2 cubed because it's 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 is 8. So we can think of that as 2 cubed. And that helps us because it's saying that if you have y cubed plus 8 and we need to solve this for y, if we just do this and take the cube root of both sides, it's kind of difficult to read our solution. So what we do is we write this as a sum of cubes and factor. Does that make sense? Okay. What other questions do you have? So go ahead. You have y cubed plus 2 cubed. We said y is acting as a, 2 is acting as b. So go ahead and take a minute and factor that. All right. So this formula is the sum of cubes. This is a sum of cubes formula. Okay? So using this, we said A is y, B is 2. So now we want to figure it out. I gave you time. Tell me what it is.
Parentheses, y plus 2.
Yes?
Times.
What goes?
Oh,
Parentheses, yes?
parentheses, y squared minus 2y plus 2 squared,
And 2 squared is?
4
4, yes?
equals 0.
Yes. Very good. Very good. So all of you, when you have this and you have the 2 squared, you are absolutely correct. Go ahead and write out what 2 squared is. Does that make sense? Everybody on the same page?
Yes.
Okay. So now what we want to do is we want to solve. But notice that we have a quadratic equation right here that you can factor for it, or you can use the quadratic formula. Here, this one doesn't factor as easily. Or does it? Does it?
Yes.
You say yes? If it factors easy, what is the factorization?
Wait, what was the question?
Yes. So I'm saying here we can solve this. So let's pause. So this means y plus 2 equals 0. Or it means y squared minus 2y plus 4 equals 0. You are not in my mind, but we can write it out so we can all be together. Okay? And I'm glad you did that. So we have y plus 2 equals 0, and we have y squared minus 2y plus 4 equals 0. Yes? What's your question?
Where did you get the two? Wait. Where did you get the two squared from? Is that cube or square?
Where? What line?
It's the top.
Which line? 1, 2, 3, or 4? This is line 1. This is line 2. You have y cubed plus 2 cubed. So 8 is the same thing as 2 times 2 times 2, which is 2 cubed. And then we used this formula to rewrite this equation here. Yes? Because 4 is the same thing as 2 squared. So initially, this is 2 squared. 2 squared is 4. Because that comes from your b squared. Does that make sense now? You weren't the only one with that question. So remember A, this is why I gave you all time. If you step out, you still got to come back in and you got to get back on it. Remember, A is y. A is y. And B is 2. And so everywhere you see an A and B, that's where you got to put those. Okay? So then we have this y plus 2 equals 0, or we have y squared minus 2y plus 4 equals 0. Here, what do we do to both sides? Subtract 2 to get y equals 2, yeah? And over here, say what? Oh, yeah, good. Y equals negative 2. Good. Does that look like negative 2? Yeah. Okay. So then over here you have y squared minus 2y plus 4 equals 0. And so whenever I was saying earlier that you have 4 different ways you can solve this, right? Factoring it is not so easy in this case. Or do you think it's easy to factor? No? I see heads shaking no. Yes, you can always ask a question.
Will we have to use the quadratic formula?
Oh my gosh.
Or no?
Yeah, you can use the quadratic formula. Yeah.
Is it, like, necessary?
Yeah, it is.
That's why I'm asking that question, like, is it, like,
It is. It is. It is here. Yeah. Because the completing the square would take too long. Factoring, we already ruled that out. Perfect square method is an option, but you have to go through and create that, right? And so then we go to our quadratic formula. So remember, because you love it so much, it's negative b plus or minus the square root of, bless you, b squared minus 4ac all over 2a, yes? That's our quadratic formula, just to remind us. That is our quadratic formula. Okay? So, now what we need to do is we need to apply that to this part. What is our a from this part?
Y.
A is what? No, it's not y. Let's remind ourselves that the standard form is ax squared plus bx plus c equals 0. That is not in, let me put it in a different place so you don't confuse what it is. For ax squared plus bx plus c equals 0. Knowing all of that, what's our a from this? Yeah, go ahead. Yes, it is. Keep going. What's b? What's b? Negative 2. Good. And what's c? Very good. Excellent. So now we use the quadratic formula. So our variable is y, so we get y equals negative b, so that's negative times negative 2, which will give us a positive 2, plus or minus the square root of what? B squared, which is the quantity negative 2 squared. That negative 2 is in parentheses. It needs to be, because otherwise it's going to look like you have a negative 1 times 2 squared, which is not the same thing. Okay? Minus 4 times what? Give me the values. 4 times. Yes, all over 2 times. Yes. Now we simplify. That's equal to 2 plus or minus the square root of negative 2 squared is 4 minus 4 times 4 times 1 is 4 times 4 times 1 is negative 16, minus 16 because that negative was out front. No, that's a good question. So the question was, would that 4 be a negative? No. So this is why we put that negative 2 in parentheses, because if the negative 2 is not in parentheses, it looks like negative 2 squared. This would be negative 4. But whenever you have negative 2 squared, that's negative 2 times negative 2, which is a positive 4. That's why the parentheses matter. Good questions. Does that make sense? Okay. All over here, what?
2.
Yeah, good. 2. So, because I'm running out of room, I'm going to move to horizontally. So we have 2 plus or minus the square root of negative 14. Nope. Yes. Negative 14. No. Jeez. Negative 12, yes. All over 2. Can I erase the yellow? That's equal to 2 plus or minus. I'm just going to rewrite it so you can see it. Negative 4 times 3. All over 2. And what is the square root of negative 4?
2.
What is it? Square root of negative 4? 2i. And notice we don't have to worry about the plus and minus because we already got plus and minus here. So plus or minus 2i times the square root of 3. All of that over 2. Now notice that notice that we can write this as 2 times the quantity, 1 plus or minus I times the square root of 3 all over 2. What do we do in our numerator? Nope, we didn't divide. What do we do to get in our numerator to get from this step to this step? What do we do in our numerator? We factored out what? We factored out the 2. Good. We factored out this 2. And so then these 2's cancel to leave us with what?
1 plus minus I square root of 3.
Good. So our solution set is what? Yes?
Or 1 plus or minus
1 plus or minus, go ahead.
the square root of 3.
What?
Oh, I to the square root of 3.
I times the square root of 3. And whenever you say I to the square root of 3, it makes it seem like square root of 3 is an exponent. So I times the square root of 3. Good. This is our solution set. Very good. What questions do you have? Yes?
Can you explain that about the third line to the fourth line again? I was driving.
Which, this line to this line?
Yes.
Okay. You said third and fourth, so I started here. So good. Thank you for the description. So here, our numerator is 2 plus or minus 2 times I square root of 3, all over 2. And so this term and this term, they both have a 2 in common. So what we're going to do is we're going to factor the 2 out of both. So whenever we factor a 2 out of both, it's really 2 times 1 there. So this is where that 1 comes from. Does that make sense? Okay. What other questions do you have? Yes? This one? Uh-huh. This too? Good. Not good. We're going to clear it up, but good. I understand your question and stuff. So I'm going to do an aside in red to answer that question. So we have, are we okay with knowing that it's the square root of negative 4 times 3? Okay. So this is the same thing as the square root of negative 4 times the square root of 3. Are we okay? Okay. This is the same thing as the square root of negative 1 times the square root of 4 times the square root of 3. What's the square root of negative 1? I. What's the square root of 4? 2. Because this is the square root of 2 squared. And times the square root of 3. And this 2 cancels with that radical. So that'll give us the 2i square root of 3. What other questions do you all have? Is having this time helpful whenever you asking questions and things?
Oh, yeah.
Okay. What other questions do you have? Okay, let's do one more. Let's do part C. The others are just examples. They'll be in the video, okay? Questions? They'll be in the video, okay? Are you with me?
Yes, ma'am.
Okay. So, part C, we have 5z cubed plus 28z squared equals 49z. What do you think to do first? Yeah, that's good. Great intuition. So 5z cubed plus 28z squared, and you said subtract 49z from both sides. So that gives us this. What do you think to do next?
Factoring.
Factor out what?
Oh, you can do the quadratic formula, right?
Oh, can we do the quadratic formula?
What's 3?
What's preventing us from doing the quadratic formula? The exponent is the variable of highest exponent is what? The variable with the highest exponent is z, but is to the highest exponent itself is 3, as you said. Yes? So that's preventing us from doing the quadratic equation. If we had z squared, then we can go ahead, or the quadratic formula. If we had that, then we could go ahead and do that, the quadratic formula, if we had z squared only. But we look, they all have what in common? They all have z in common, so we can factor the z out, yeah? And when you factor the z out, what do we have left? Z times minus 49. All of that quantity times z is equal to 0. So you're at a point now where you get z equals 0 or 5z squared plus 28z minus 49 equals 0. So you have that. So if you want to use the quadratic formula for the one on the right, then you can do it. I'm going to choose to factor it just to show you another way. You can use the quadratic formula. You'll just be dealing with large numbers, and that's okay. You can do it. You're going to get the same exact thing. Okay? So one answer, z equals 0. We get it. Here, you can factor it if you want to, or you can use the quadratic formula. I'm going to factor it because whenever we look at these numbers, 5 is a prime number, which means it's only divisible by 1 and the number itself, 5. 49 can only factor as 49 and 1, or positive 49 and negative 1, or vice versa, flipping the signs, or positive 7 and negative 7. That's the only option. That's why I'm choosing a factor. So you have 5z, we're going to put something there, and then we need to have a z there. That product is going to equal 0. We want our middle term to be positive or negative? Positive, right? So because we see a 5 here, and we know if we can do a 49. If we choose 49 and 1, our numbers are going to be too large. So the only option is going to be a positive 7 and a negative 7. Where do we want the negative to go? Where do we want the positive to go? We want our middle term to be a... Put the negative with the 5z. Good. Oops. Why did it do that? 5z minus 7 equals, or times the quantity z plus 7 equals 0. So then we solve. We get 5z minus 7 equals 0, or we get z plus 7 equals 0. We do what to both sides? Yes. To get 5z equals 7, divide both sides by 5 to get good. And then we do what to both sides for the other one? Yes, to get z equals negative 7. Good. So what's our solution set? That's it?
And 0.
Oh yeah, 0 too. Yeah, so as you saw, it's easy to forget this first one. So what you may want to go ahead and do is like block it or something, so they all stand out.
We got three
Solutions, which makes sense because our highest exponent was 3, so we should have 3 zeros, 3 solutions. Okay, have a good one. See you next Tuesday. Make sure you do your homework. I have office hours today. Come and see me.